Most of people take a pill or receive an injection or otherwise take some kind of medicine during their life, but most of us don't know how these substances really works. How can various compounds impact the way we physically feel, think, and even behave? For most part, this depends on how drugs alter communication between cells in the brain. There are a number of different ways that can happen, but before it gets into the brain, any drugs must first reach a bloodstream on a journey that can take anywhere from seconds to hours, depending on factors like how it administrated. The slowest method is taking the drug orally because it must be absorbed by our digestive system before it takes effect. Inhaling a drug gets into the bloodstream faster, and injecting a drug works quicker because it pumps a chemical directly into the blood. Once there, the drug quickly reaches the gate of its destination, the brain. The entrance to this organ is guarded by the blood-brain barrier, which separates blood from the nervous system to keep potentially dangerous substances out. So all drugs must have a specific composition which gives them the key to unlock this barrier and pass through. Once again, drugs start to interfere with the brain's normal functioning by targeting its webs of neurons and synapses. Neurons are the brain cells that have nucleus, dendrites, and an axon. Synapses are the structures placed along the dendrites or the axons, which allow the exchange of electrochemical signals between neurons. Those signals take the form of chemical called neurotransmitter. Each neurotransmitter plays different roles in regulating our behavior, emotions, and cognition. But they all work in one of two ways. They can either inhibit the receiving of neurons, limiting its activity, or excite it, creating a new electrochemical signal that spreads through the network. Any leftover neurotransmitter usually gets degraded or reabsorbed into the transmitting neurons. A drive effectively stems from its about to manipulate these synapses. Transmission at different phases of the process that result in an increase or decrease in the amount of neurotransmitter being spread. For instance, common antidepressants like SSRIs stop the reabsorption of serotonin, neurotransmitter that moderate moods. This effectively pushes more of its neural network. Meanwhile, painkillers like morphine raise level of serotonin and noradrenaline, which regulate energy, arousal, illness, and pleasure. Those same neurotransmitters also affect the endorphin receptors, reducing pain perception, and transcranial works by increasing the production of GABA to inhibit the neural activity, putting a person in a relaxed or sedated state. What about illegal and illicit drugs? These have powerful impact on the brain, and we are still trying to understand the crystal meth and amphetamine induces a long-lasting release of dopamine, a neurotransmitter linked with the perception of reward and pleasure. It also activates noradrenaline receptor, which increase the heart rate, they dilate pupils, and trigger body fight or flight reactions. Cocaine blocks the uptake of dopamine and serotonin, pushing more into a network where they boost energy, create feeling of euphoria, and suppress appetite. And hallucinogenic drugs have some kind of most pleasing effects. Substances like LSD, mescaline, and DMR all blocks the release of serotonin, which regulate mood and impulsivity. They also have an impact on neural circuits involved in perception, learning, and behavior regulations, which may explain why these drugs have such powerful impact. Even if some of these effects sounds exciting, there are reasons why some of these drugs are highly controlled, or often illegal drugs have the power to alter brain chemistry, and repeated use can permanently rewire the neural network, support our ability to think, and make decisions, learn and remember things. There are a lot we still don't know about drugs and their effect, both the good and the bad. But most of us do know that we are the ones study closely and turn into effective medicine. As our knowledge thrives about drugs and brains, the possibility will also increase for treating many medical problems that puzzle researchers today. Thank you.